Welcome to the ClearOne University and the StreamNet View Pro Certified Product Specialist course. This module covers color space, high-quality digital videos captured in a format called RGB 444. This requires 8 bits per color per pixel and is expressed in the RGB 444 notation. Each pixel in the image is going to produce the correct luminance and chrominance data, which will require 24 bits per pixel. And as you know, as the resolutions increase, the amount of data needed to produce and transmit that amount of data will grow. So for this reason, there are compression methods such as chroma subsampling and other data compression methods and codecs such as H.264 that have been developed to help reduce the amount of data required. According to science, we know that the human visual system, or HVS, is more sensitive to changes in luminance than in the differences in chrominance. Chroma subsampling is a method that takes advantage of this by reducing the chrominance resolution while maintaining full luma. The first step in producing a chroma subsampled is to reformat the data from the RGB 444 into YCBCR 444. This first step still has not reduced any data. You still have full horizontal and full vertical resolution, but it is necessary in order to format it and go into the compression steps that we'll outline in the next slides. Now, when you see the notation 444, that's really describing how many luminant samples, so the first digit refers to how many of those full samples, you have 4 luminant samples, and for every 4 luminant samples, then the second digit refers to how many chrominance samples per the 4 luminant samples. And the third digit is referring to how many vertical samples as opposed to the 4 luminance. And so you're going to see that expressed, and we'll cover that more thoroughly in the next couple slides. If you look at the 3 color blocks on the bottom of this slide, the only difference of those 3 blocks is the luminance value. And so that just gives you an example. The way chroma subsampling works is by reducing the data that was developed originally in the YCBCR color dataset and replaces that data with adjacent pixels. So each subsampled pixel keeps all the original luminance data, but it borrows the data from an adjacent pixel for the chrominance. And so if you look on this slide, this particular type of chroma subsampling, your 75% of the image is borrowed from adjacent pixels. And so you only achieve a 50% vertical and 50% horizontal resolution with this. Now let's take a look at a couple of these notations for popular electronic equipment. 311 is a popular one you'll see a lot, and this is the method where the chroma samples are processed with every 3rd luma sample. And so the data reduction is a 2-to-1. It's pretty good reduction, as you can see on the image there. And the type of device that produces this is your typical digital high-def camera, including those ones that say full HD resolution. When they're saying full resolution, they're really talking about the pixel count. But they don't say on those stickers is that they're chroma subsampling, and so you only have, in this particular case, 1/3 horizontal resolution. And so that's a common one you'll see out there. Next up, we're looking at 411, and this is where the chroma samples are processed with every 4th luma sample. You still have a 2-to-1 data compression. And it's a pretty common one for things like set-top boxes. Now this notation is probably the most popular and most common of all of the notations, and this is the 420. So you have chroma samples processed with every other luma sample. The loss of the data reduction is a 2.1, a lossy compression. Very popular on many formats, including Blu-ray, which is most famous for, but also this is what you see on your HD Base T and your Crestron DM type systems as well. Now 422, not quite as common as you see on 420, but starting to be kind of an up and comer, and you'll see why on the what it does on the pixel wise. It's not as good of a data compression. It's only a 1.5 to 1, considered kind of just a lossy compression. So you have a chroma sample that are processed with every other luma sample, and you see this now on things like the Red Ray, the media servers. This is right now the highest profile in the AVB profiles, for example. Now this last notation we'll show you is what is called the YCBCR 444. It's kind of what we started the whole thing off on. There is no compression in this, so every chroma pixel is processed with every luma pixel. Because of that, there is no compression, no one-to-one, so it still takes the 24 bits, per pixel on there. And you will see some sources that can do this. Some high-end broadcast quality cameras can do this. There are certain MacBook Pros that can put out this. And if you're on a workstation, there are some very high resolution, high cost video cards that you can put in with 444 outputs. Now, inside the ViewPro system, you can create the profiles, as we learned earlier, in these presets, video presets. So you can actually create a 420 stream and a 444 stream. And so since we have that capability, I wanted to put up the same image so that you could see the differences between the two. If you look really carefully in the eye, you'll really see some differences, and to the left of the image in those circles where the lines going through them are. One more image showing the 420 versus the 444 on the same source. If you look, I've zoomed in even further up in that blue area in the middle and in the eyes is where you really start to see the detail that is gained when you can send the full color the entire time. Also, one last thing to remember, you cannot produce deep color if you do not have this 24-bit true color at the display. You're now ready to take the quiz on this module. The next module is for H.264 compression.